Welcome back, dear students. Today we are still on the abstract data type trees, and today we are looking at a particular type, a very important type of binary trees, which is the binary search tree, a BST. Also known as an ordered or sorted binary tree, a BST is a variant of binary trees in which the nodes are arranged in an order. So when we were talking about trees, we saw binary trees. We never made mention about the way the nodes are being arranged. We just know that a tree is is a connected graph of a connected graph containing nodes and it does not form a cycle. And we went further to see binary trees where we said binary tree is a tree in which each node had at most two children. But now we are in a particular type of binary tree, which is a binary search tree, where the nodes are arranged in a particular order. Now, the following are the properties of a BST. The left subtree of a node contains only the nodes with keys less than the node's key, meaning that all the values I have on the left of a particular node should be less than the node itself. The right subtree of a node contains only nodes with keys greater than the node's key, so the values to the right are greater than the node itself. The left and the right subtree each must also be a binary search tree. So the left and the right must be a BST, and then there must be no duplicate of nodes. Very important, because the first two properties you are talking about those nodes that are either less than or greater than. We did not make mention of being equals. That is why we said there must be no duplicate of nodes. So these are the four key properties of a BST. Now, let us see how to draw a BST. When given data to draw a BST, pick the first element of the array and make it the root. So when we are given a set of values moving from left to right, our first value we have is our root. Then the second one says pick the second element. If its value is smaller than the root node value, make it the left child. Else, make it the right child. Number three, recursively perform step 2 and step 3 to make a BST. As all as that. Now, this step might seem ambiguous for some students and seems clearer for others, but I am sure in what case you are present, you will be satisfied after some examples are solved. Now, use the sequence of numbers 7, 4, 12, 3, 6, 8, 1, 5, 10 to produce a BST. As the first step says, you pick the first element and it is our root. So that what we have, our root here is 7. From there, we'll take 4. If you compare 4 and 7, 4 is less than, so 4 has to be to the left. That's what we have. The next input is 12. When you compare 12 and 7, what do you have? 12 is greater than, so it should be to the right. The next one is 3. When you compare 3 with 7, 3 is less than, so I'm coming here. I compare with 4 again. How is 3 compared to 4? 3 is less than, so 3 has to be to the left of 4, as you are seeing. The next one is 6. When you come here, 6 is less than, so we are coming here. 6 is greater than 4, so 6 comes here. The next one is 8. When you compare, 8 is greater than, so we come here. When you compare 8 and 12, 8 is less than 12, so we are here. The next one is 1. When you come here, can you point the position? Just put your finger where 1 is supposed to be. Okay, let us see. When you come here, 1 is less than, so we are here. We come here, 1 is less than, we are here. Come here, 1 is less than, so we move here. If that is where your finger was, that's perfect. You are just above the name of one of the outstanding channel we have for Advanced Level Computer Science 795. Let's proceed. The next one, 5. Where will 5 be? Let us see. When you compare 5 and 7, 5 is less than. When you compare 5 and 4, 5 is greater than. When you compare 5 and 6, 5 is less than. So this is where 5 is supposed to be. The last one, which is 10. When you compare, 10 is greater than, 10 is less than, 10 is greater than. So we are here. And you can clearly see that each node at the same level are on the same line. So we can clearly, what is the level of, what is the height of this particular tree? Height 0, height 1, height 2, height 3. So this tree is having as height 3. And this is simply how we draw a binary search tree when given input. Now you might ask yourself, what if our input is a set of characters, that is string values? Remember that you are present in one of the best channel, Advanced Level Computer Science. So that is why all different kinds of questions that you might see are present in this channel. So let us take one of an ancient June, that is June 2011, question 4 sub 2. The question says, what is binary tree? Give one example of the use of binary tree in computing. Sub 2 says the following data on the regional headquarters of Cameroon are to be entered in a binary search tree in the order given. We have Amenda and so on. First, draw a binary tree diagram showing how the above data will be stored. How many nodes are there in the diagram? If Douala is being searched for the above tree, list the data item that must be accessed. So this is a question that came just the sub 2 part of question 4, and it came for 9 marks. So now, what is a binary tree? We know that a binary tree is a tree in which each node has at most 2 children. And one example of the use of binary tree in computing, we have expression trees, we have files and folders. That is the path of some files. It can be viewed as a binary tree, which facilitates searching. Um, we also have the management of data, because in a tree we can easily traverse and get a particular data because it is already sorted. For a BST, we are going to look at this application of trees in the subsequent videos. So I just wanted to explain to you. So now solution, I did for the first one. The next one, we need to draw our BST. So our first node is the root. So I have my Bamenda, which is the root. From there, Marwa. Here we are comparing the first characters, M and B. We see that M is above B in the alphabet because M comes after B, so it is greater than. So Marwa comes to the right, because remember that those that are above goes to the right and those below to the left. Now, when you compare this Bafusam and Bamenda, you see that they have the first character are the same. So you move now to the second character. They are still the same. You move to the third. Between F and M, who is above? It is M that is above. So Bafusam is below Bamenda. So this is what we have. The next one is Ngaundere. N is above B. So we come here. When you compare N and M, we know that N comes after M. So this is where Ngaundere is to the right of Marwa. Then we have Ebolowa. E comes after B. When you come here, E comes before M. So this is where Ebolowa is going to be. The next one is Betwa with B. The first character are the same. Then we have E. And you see that E comes after A because the first character are the same. So we compare now the second and we see that E is above A. So Bamenda Betwa goes to the right of Bamenda. We come here to the right. When you compare Betwa and Marwa, B and M, because when you're coming here, you start back at the beginning of the comparison. B and M, we know that B comes before M, so Betwa is to the left of Marwa. When you come here, you compare again between E and B, who is below, and it is Betwa. So Betwa has to be to the left of Ebolowa, as you can see. The next one is Yaoundé. Y is above. When you come here, Y is above. When you come here, Y is still above. So this is where Yaoundé is. The next one is Douala. D is above B. When you come here, D is below. When you come here, between D and E, which one comes at A, B, C, D? So D comes before E. So we come at the left because D is lower. So we come here. When you compare D and B, we know that D comes after B. So this is where Douala is going to be, to the right of Betwa. The next one is Garoua. When you come here, because comparison of every node starts from the root. G comes after Bamenda. G comes after B. When you come here, G comes before Marwa. So we go to the left. Between G and E, we know that G comes after E. So this is where Garoua is supposed to be. Now, you watching this video, can you point where Boya is going to be? Let us see. When you compare, first characters are the same. Second character, U, is after A. So we are here. When you compare B and M, because you're on Boya, B is below. We come here. B and E, B is below. When you come here, the first characters are the same. When you compare U and E, U is after, so Boya comes to the right of Betwa. When you compare here, Boya and Douala, B comes before D, so Boya is supposed to be to the left of Douala. And this is what we have. This is our binary search tree based on the string values that were given, dear students. So we are done with this question. The next part says, how many nodes are there in the diagram? So how many nodes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 nodes. We are done with this other question. The next one says, if Douala is being searched in the above tree, list the data item that must be accessed. So if I want to arrive at Douala, searching always starts from the root. So I start Bamenda, Marwa, Ebolowa, Betwa before I reach Douala. So for Douala to be searched, Bamenda, Marwa, Ebolowa, Betwa must be accessed before we reach Douala. It does not mean that you that is in Bamenda, before you reach Douala, you must go to Marwa, Ebolowa and Betwa before reaching Douala. No, it is simply based on how the BST stores its data. So if you are searching, for example, if you have a particular program that have these different cities stored using a binary search tree, then to access the information stored in node for Douala, you need to visit the nodes of Bamenda, Marwa, Ebolowa, and Betwa before arriving at Douala. So that was all for this June 2011 question 4 sub 2. And as our tradition says in Byte by Byte, after a successful explanation and example done, you, the students, you need to try in order to be sure you understood the concept. So as exercise, we propose to you the Bamenda Mock 2022 question 4, where you have all these questions. Very interesting. It is a full question, and I'll be glad to see those who will be able to attempt to this question, because it goes from the beginning, where you have a distinction between linked list and binary search tree, drawing the binary search tree, determining the height of the binary tree, giving the in order, pre-order, and post-order traversal. Wow, very interesting. Now, using a while loop and a for loop, write two separate algorithms to print the sum and average. Explain the main difference using the above control structure. So it goes from the beginning, that is arrays. It goes to linked list, it goes to binary search tree, it goes to traversals. This is a very nice question, dear students, because it groups all what we have done up till now under data structure. So I am waiting for your reply. And do not forget, the solution will be posted during the weekend, mostly, as always, on Sunday. In our next video, we are going to see how a binary search tree is modified after the insertion and the deletion of a particular element. Do not forget to like, to subscribe, and to share this video to your students, to your colleagues, dear teachers, in order to increase our community. And why not drop in a comment which will serve as a feedback to our team. Thank you, and see you in the next video.